Perfect. Okay, so I'm Georgia Kutrika. I am the coordinator for the DataGEMS project, and I am a research director in Athena Research Center in Greece. My interest and my group also interest lie at the intersection of AI and data management. So as you can suspect, the DataGEMS is very close to my heart. So let's first see what is the problem that we try to tackle with the DataGEMS. And the problem is not the lack of data. It is actually the abundance of data and the fact that data discovery does not work. And why this is happening? For four main reasons that I'm pretty sure that everyone is aware of. First of all, data volume and diversity. We're dealing with tons of data, diverse data types. It is hard for a user to cope with and to explore and to find data that are specific to their information need. And of course, the tools that we currently have at our disposal, well, behind the scenes, most of them are keyword-based search algorithms, where essentially they do not understand very well user intent. They do not understand very well the semantics of the data sets, the purpose of the data sets, where these data sets are appropriate for, and as a result, they yield irrelevant and superficial results oftentimes. A big problem and a big reason, a big factor for this is that we do not have a rich contextual metadata and descriptions for our data sets. If you go through existing data marketplaces or data portals, we see there data that focuses on provenance, who created this data set, what are the license, and so forth. But we don't see so much semantic and contextual details that help both users and the systems have a better grasp, a better understanding of the data. And that is why when, as users, we search for data and for answers within the data, we have to resort to manual evaluation and inspection, and that takes forever. And that is also coupled by the lack of advanced querying and user guidance tools. For example, absence of cross dataset analytics, how different datasets can be combined together to give added value to the user, as well as lack of tools that can help the user, that can guide the user, if you like, in this ocean of data, and that restricts again multi-source data. So what is DataGEMS trying to achieve? 5 big bets, novelties, if you like, satisfying a comprehensive data life cycle, where here we want to offer a unified architecture, if you like, or solution that can help share, store, manage, discover, and reuse data efficiently. And of course, you can see the data life cycle having a complete one as the one that we just described, but also having parts of it. For example, one may want to focus more on the discovery part or the managing part. A big pillar, a big bet of our project is the semantic data profiling capabilities, where essentially here we are building profiling mechanisms that essentially come and enrich data with rich metadata that can help validate dataset relevance, that can help interpret the semantics and of the data and use it appropriately. Next generation data discovery tools that are based on natural language searches, on complex pattern recognition. For example, you may have a pattern that describes a specific time series, and you would like to match this to other existing time series from real-time sensors, and ranking that takes into account not just the a high-level metadata, but also the content of the dataset whenever this content, of course, is available. That next generation data discovery is coupled, of course, with analytics and guidance, tools that help the user get recommendations about other data sets that may be similar to the ones that he's currently examining or complementary to the ones. And for the latter, we auto-assemble data packages that comprise of more than one data set that if they come together, they may have more information or they may fit the user need and purposes better. And of course, also exploration of workflows, because the user may not know exactly how to proceed, what to look for. It is one of the most critical requirements to be able to suggest next steps to the user or even complete paths within the available data repository. And of course, this has to be done for diverse data types. So we're working with structured, semi-structured, historical, real-time data sets, and so forth. So the project objectives, we covered them already in some form or the other. I would like to focus to stress here that we have started with 4 diverse use cases: education, meteorology, lifelong learning, and language, and of course, sustainability and fair compliance, as well as stakeholder engagement and scaling for EOSC are one of they are very important for us and for the project. Now, these are the partners coming from different countries: France, Italy, Greece, Switzerland, Portugal. What am I forgetting? Poland, Spain, of course, Germany. So we have a very nice mixture of partners here with complementary expertise, and that is one of the great things for the project. So here is an architecture of the project, of what we're building. I don't want to, I'm just putting it here for, having something more complex to look at, but I want to spend maybe 5 more minutes to describe a little bit more what the different components, the different green components that you see here are trying to do. I'm not going, of course, to go into technical details right now, since this is our first meeting, so I don't want to tire us. So semantic data profiling, as we already said, is one of the main pillars of the project. And here the mission is to deliver the profiles of data sets that can be used both from users to understand the data, to be able to see if the data is relevant for their purposes, but also these profiles are meant to be used by the system, by our smart algorithms, to enable better exploration of the data, better results for the user. So here the goal is to extract important information that comes from any type of different formats, either structured files like CSV, table, relational tables, and so forth, text, images, real-time data in the form of time series. So essentially, the 4 core problems that we are working on is the structured data profiler that extracts statistics, summaries, semantic information from structured data, for example, from tables. The unstructured data profiler that does the same thing, but now the problem here is how you deal with documents, for example, encyclopedias, legal documents, any type of, in any format, for example, PDFs or HTML files. Time series, where here we try to first to understand anomalies and interesting things that can be observed in the data and in real time. And one important component here is a dataset linker, because one data set can tell one story, but if you bring more than one related data sets together, this can have more value, they can tell more things. So how you discover these potential links and relationships between the data sets is a very crucial problem and very important. Behind the scenes here, there are multiple different algorithms at different levels, from LLMs and machine learning techniques to simpler ones like rule-based, depending on the type of information we want to extract. Now, the second big pillar is, of course, data discovery. And here we want to enable the discovery and exploration of the data sets, which means that first we want to be able to, and we already have advanced search for data sets. So you can search about different data sets using natural language, but then you can also search answers within data sets, looking inside the contents of a data set, again, using natural language and patterns and examples and so forth. And we can combine data sets, building what we call bundles or packages to satisfy a user need that cannot be met by one single data set. So you may, for example, be looking for how, I'm just saying a random question here, how the weather in Athens impacted the employment rates. Okay, so this type of question cannot be answered by a single data set, but it needs, for example, one data set talking about weather in Athens in a particular period, and then there are other data sets that talk about employment statistics, how these are linked, how these correlate, and which combination is best for the user. These are the things that we do here. So the four major problems that we are dealing with is data set search, how you find relevant data sets, exploration, how you find answers within different data modalities. So again, when we say data sets, it can be many different types of things, documents, images, files, and so forth. How we bundle together data sets, as we said, to increase their utility. And of course, we also want to be able to manage and reuse analytical workflows. So by this, we mean different steps that can lead a user to the desired outcome, to the desired results or data sets. And we want to be able to store, manage, and recommend such workflows to help the user navigate the data. So more on this is the third pillar, assisting users in their data tasks. And here the mission is to provide recommendations that can help the user find what they're looking for, but also understand the user intent and align with the user intent, which is very important. Otherwise, you may return results that are totally irrelevant to what the user is really looking for. And also another important thing, offer transparency by explaining the reasoning behind generating system responses. And this is important because the algorithms behind the scenes in the system use, of course, AI and LLMs, large language models, a lot. So one of the bet and our challenge here is to make our algorithms explainable and transparent to the users. So the four core problems here are recommending queries to the user so that they can proceed and continue their research. Disambiguate, clarify what the user means. Recommend different data sets that can help the user depending on the context where the user is right now in its search journey. And explaining, as we said, by analytical pattern explanations, explaining what is happening, why the user is seeing this particular answer from the system. Behind the scenes, everything is unified by a unified data model that brings together data sets, metadata, machine learning models that are used to access or to generate or to modify these data sets, workflows, of course, and this model and this layer that sits at the bottom of all these different services helps to provide a structured support for tracking interactions, tracking provenance, the evolution of data and workflows within the system, and so forth. The provision of what we call the DataGEMS platform, so bringing everything together, is of course another and a big important pillar that has to do with end-to-end integration, with operationalizing big word services, and of course integration with EOSC and support onboarding. And so this is how the different services look like in reality. I'm just showing this as a complex figure. And at this point, I would like to pass the floor to Eleni. And Eleni, please let me know when I will click the next slide.
Thank you, Georgia. Hello from my side too. I'm Eleni Petra. We know, I think most of all of you, of participants today, one of the very basic and very central objective in our project, as all of our projects here of presentation, is the linkage and the connection to EOSC Federation, to EOSC objectives. DataGEMS focusing very much on the alignment of the EOSC Federation in total, with all the nodes that are connected to our partners, either in thematic direction or national direction. For example, the EOSC node in Poland is very much connected to our Polish, is going to be connected to our Polish partner, IDECO, and thanks to the Winter School that we participated, we are going to introduce all this relationship with Poland, new EOSC node. At the same time, we are very much aligned with the European EOSC node, and we're trying to make all the activities happen in the next months, together with the alignment of openness and fairness ecosystems, in other words, with the services and provisions coming from the open air. We already used Zenodo. All our DMPs are going to be implemented by using and adopting Argos facilities and services. And at the same time, as you can see it on the right up corner, we've been already connected to either to nodes, to European nodes related to infrastructure, like the UDAT node, thanks to discussion we've been realized in the last Winter School, and also to the infrastructure related to our services, either the data use cases connected, like clearing and FDI from Germany, or the AND for services related to a central provision from our project. Next slide, please. I think it's work packet 7, Georgia. Yes, with regards to the evaluation of our services provided and use case at the same time, one of the very basic and very important work packages from our project is the evaluation phase and the evaluation activity coming from our project. And one of the work packages that is very connected to that is CNRS, and Sarab is here today. The evaluation is going to be happened through different pilots representing our different use cases. The 4 use case direction that we have presented before in 5 different countries, actually 20 pilots in the coming months, in order to evaluate the provisions of the DataGEMS in relation to data, system, and human. And why evaluations? Because DataGEMS system will accommodate with different data access and data discovery approaches, and these different approaches will create different user experience, and we very much depend on this in our project. And you're going to be informed about that. All of these 3 projects that are connected under the same call, you're going to be informed, and we like very much to be aligned and to be together on this pilot's experience in the coming months. I think that's all. And thank you for your attention.
Thank you very much, Elena and Georgia. I will give the floor right away to EOSC Data Commons, which will be in order, if I'm not mistaken.
Yeah,
Are you here?
that should be me.
Oh, great. Thank you.
Let me share my screen. 1 second. Can you confirm that you see the slides?
Yes, we do.
Thank you. So I will, try to make it fast because some of us have already seen this presentation, so I don't want to get too much into repetition. So EOSC Data Commons, we know it's one of the projects of this EOSC 0105 call. We started in April, and will take 36 months. And we have 22 partners in the consortium from several countries. And we have divided them in 3 big categories. The first one would be repository owners. So we have a set of either national or international or thematic repositories that are coming to the project to make their data discoverable in EOSC. Then we have a set of partners that are more the technical developers, the technology providers, so developing the solutions that are coming in the project. And then we have a few research communities, also several partners contributing here. We have actually 13 use cases in the project. And then we have EGI Foundation as the coordinator. The overall objective of the project is written there. What we want to do is contribute to establishing EOSC as the European Research Commons by federating repositories for national, institutional, and thematic initiatives with a metadata warehouse of paired data and software for use and reuse in data sets across the compute continuum. So lots of words, but basically we want to bring repositories, data from repositories, make them discoverable in EOSC, have metadata around the data available in those repositories, link them with software, and then make it easy to just analyze those data with this software that we are linking with. Hopefully making that the data sets that are already available are reused and new research is produced with them. We are doing this by building a set of services, and I will just try to describe it, the main parts of our approach. So kind of what I already say, we have these repositories that are there in production, available in Europe, but either they are not super easy discoverable, not as easy to find data that is available there, or they are just standing in isolation, so you cannot relate data from one repository to another. That could be helpful in certain cases. So we have these 5 multidisciplinary repositories. We have HAL from France, Science Mesh, that's CERN, DAVAR in Croatia, Sonoro is just pan-European. Now dance in the Netherlands. And then we have thematic repositories from the humanities, Earth observation, or bioinformatics from different countries. And all of these, the idea is that they come together in the EOSC Data Commons, and we create a new common discovery channel for the data in these repositories. This is also the care number 2 of our project, the Federation of Data Repositories. And the idea is that we provide on top of that not just a simple query, but also AI-based natural language search tools over this rich metadata warehouse. So you can do this kind of natural language queries over the data sets, and you don't need to go and be super specific just with a just with a natural language query will allow you to find the data that you're looking for. And the kind of the second part of the project is this linking this data and analytics. So beyond these data repositories that we harvest, we also harvest tools coming from also several repositories out there or existing workflow engines or workflow repositories. We bring all these tools into this metadata warehouse, and what we do is we link the data and the tools that are compatible with the data, and we provide what we call a package for processing data set that can be used then to be submitted into the infrastructure to do the actual analytics. And here we have a set of other key exploitable results from the project. So one is this metadata warehouse and discovery service, the catalog of analytics, so the list of tools that we are able to pair with the data. We have this execution service, so given the package for processing data sets, you can execute the analytics. And this CARE 5 is the metadata specification for processing data sets that we want to promote as part of the EOSC interoperability framework. So hopefully this can be a way to share analytics and reproduce analysis within EOSC and from one node to another. We are also looking into increasing the fairness in EOSC. We are not really developing new fair assessment tools, but we are integrating existing fair assessment tools into our services with the idea that eventually we will be able to increase the fairness of the data that is available in the repositories by providing guidance to the repository owners on what could be improved to get more fair data on their repositories, but also looking at the data before it's actually published, providing a bit of guidance and support to the user that will be finally publishing this to a repository, suggesting how to make it as fair as possible, this data. So overall, the idea is that EOSC data will be more fair at the end. So this is our care number 6, this fairness assessment and reproducibility tools and policies. Overall, we will have 2 main services that are shown in this picture, the EOS Matchmaker and the EOS Data Player. So the EOS Matchmaker is the one dealing with the metadata and the discovery. And what it will do is will discover, it will harvest the metadata from the different repositories using their native APIs, so fetching all the metadata available there, not just staying at a common minimum denominator of metadata, just fetch everything together, put it into what we call the metadata warehouse, and then have the AI-based discovery on top of that. The matchmaker will also be the one delivering the user interface. It will be basically a web user interface, and it will also have the data preparation. This is the process for linking data sets and tools and producing what we call the package for dataset processing to be executed into the infrastructure. And the one that executes is the EOS Data Player, which has basically 3 components. The dispatcher takes the input and kind of coordinates the whole workflow. It talks to several analytic tools, so it can talk to Galaxy, to Jupyter, to Binder, to Kubernetes. So it's able to understand different computing or VRE facilities to be able to start the analysis, and also has a data management component that is able to understand how to access the data or how to include it into the request that is done to the infrastructure. Once everything is ready, is sent to the infrastructure, and the analysis will happen. Eventually, some results will be produced, and ideally, they will be fetched back again into the repositories, and we kind of close the whole cycle of the data that I'm showing here, the data life cycle. So in the case of the EOS Matchmaker, we are trying to enhance the workflows by connecting datasets with suitable analytic tools. We enrich and aggregate and enrich metadata from different repositories with this AI discovery, pairing data and tools, and basically we try to support all the research data lifecycle phases, hopefully making everything more fair and reusable. So this is kind of what I already said, just pointing to the exact phases where we are more looking into. Okay, and in the case of the data player, I will just put this. Again, what we're trying to do is simplifying the execution of the analytics. So you just pass this package and data player will automate all the process for having the computing environment ready, sending the input data, the computation, the software that it's needed, and then providing the user with a link where he or she can click and interact with the tool, or if it's a batch execution, just wait for the results and get it back. So as I was saying, it facilitates access to data sets and automates all the execution of data processing analysis across the whole compute continuum, from the, let's say, high throughput computing, cloud compute, or even HPC resources. And all of this is very plugin based. So we are starting with a few tools that we have within the project, but the idea is that this could be extended with any other tool and hopefully getting into a very rich ecosystem for supporting any kind of analytics. Okay. So in the sense of the interoperability, the EOS Matchmaker is looking into several repositories. As a start point, we have picked OAI PMH and DataCite 2.6, which is kind of common everywhere. So it seems like a good place to start, but we are not stopping there. So we are starting with these APIs as a first thing to harvest, but we are also using the native APIs of repository for harvesting additional detailed metadata. We're also using this AI with LLMs. Basically, we have LLMs externally to the project where we use as an inference, and we do the search using the LLM to get information or to get the search results over the basic and detailed metadata. In the case of pairing tools and datasets, we have started doing a kind of a basic pairing, saying if this file is an image, let's say a PNG, then well, image processing tool can probably be able to analyze this data set. But we are going beyond that, and the idea is that we also apply AI-based techniques to be able to better link the data sets and the discovery. At the end, we will have this catalog of tools that will aggregate and harmonize records from several repositories, and will enrich them with this information about what kind of data set can a tool analyze. In the case of the data player, we are quite actively working on having this package for processing datasets, or for datasets processing properly defined. We have started the specification based on Arrowcrate and Bagit. Arrowcrate is quite well known in the EOS ecosystem. So this kind of a fair digital object, and we are promoting this, extending it with Bagit, which is very common in the preservation area. And we are extending it with profiles that allow us to express the needs around the analytics and the data management that we have. Eventually, this package can be shared between users for reuse, can be used as provenance, and can be just deposited in a repository for others to discover and be reused. And similar to the matchmaker, we try to be compatible as with many things as possible. So we have this plugin-based architecture. We will allow to bring your own computer and data through automated deployment of tools and platforms using infrastructure manager. We are looking into offloading computation to HPC through interlink. And of course, all of this will only work if we have an interoperable AI. So we rely on the EOSC AI will be there working. And we hope this also encourages common architectural blueprints and technical specifications for federated computing storage to appear within EOSC that we believe is a missing piece right now. Just a few words on the integration with the EU node. This is our initial idea. So the EOS data player and matchmaker can be a fundamental or component of any EOSC node. And the idea is that this will be able to talk with the EOSC EU node to perform several operations. So the EOS data player will be able to manage data within the EOSC EU node and to run workloads there using the different services available. And of course, you also use the local computing resources. And the matchmaker will be able to discover not just what's federated within the node, but also potentially information from other nodes, and will expose an OAI PMH for others to discover the data available there. In particular, in the EOSC node, we're thinking on the Tools Hub as a source for analytics tools that can be used in the EOS Matchmaker. This is just showing the EOSC node, but potentially this could be any other node. And we had a first, let's say, release, a proof of concept release in November 2026. We are already working on the first, let's say, production release that will be due in June. And I wanted to show you just some screenshots on how this looks like. So this is kind of the front page of the matchmaker. When you just get there, you have this kind of simple search box where you can put your input. Here are some examples and some metrics around what we are harvesting, the number of data sets that we are getting and from where. So if you put a query there, I put this example because it's what we work in the proof of concept, a very specific use case around analyzing newspaper images. So you put just that query, and it will return some results. It will give you a ranking about the how good is matching with the query. It will also provide you a summary, and potentially you can also filter stuff. So if you click on the view here, what you will get is direct access to the original repository. But if you click on the run, it will show you potential tools that are good for analyzing this data set. In this case, it was a newspaper image. So what we thought is, okay, we could do some OCR of the images and extract the test. So the researcher could do the analysis there. So if you click on the OCR, you will get a list of the files available in the datasets, and you can just select how you want to access those datasets in the workflow, in this OCR workflow. So you could select this concentric Berliner blah 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 as an input source, and click on submit to BRE, and you will be redirected to Galaxy. In this case, Galaxy, because that's a Galaxy workflow, to just finalize your analytics. So that was already put in place in November. That's how our current use cases are testing the products, and we hope that we get it into a fully, let's say not fully functional, but with all the main features already available in June for a first implementation of all the use cases, and then we will increasingly continuously improving the project services until the very end. And you have some links here with the use cases and the services, and that's it. Thank you.
Thank you very much. I will give the floor straight away to Suzanne and Julia, who will present LUMEN.
Thank you, Sona. Good afternoon, everyone. So let me share my screen. Yeah, here it is. It's really interesting to have the different presentation in a row. I'm looking forward to the last one because at least on my side, I can see already where we can build some synergy between the project. And so it's thank you, Sona, for organizing the discussion and the workshop. So let's address LUMEN, which is about federating scientific communities through a fair data mesh, and I will explain a bit more. So there will be, in the presentation, there will be a couple of slides a bit more technical. I can present them, but I'm sure as well that Julien will be able to either correct me or replace if it is needed. So yeah, but you will see. So first, quickly, in LUMEN, so 20 partners, 9 EU countries, and it's a 3 years project coordinated by CNRS. We do have 4 objectives. First, creating a shared and collaborative cross-disciplinary knowledge and data exchange space for the next generation of EOSC, and it is mainly seen through the white label discovery platform. Enhance the qualitative discovery of research output by establishing an ecosystem of innovative features. So we will quickly show you the 8 innovative features that we have, but for instance, we have also the white label platform, the LUMEN infrastructure for semantics, and some AI enhanced services. So it's more related to the second one. Support the production of fair by design research output, something which is quite similar to what we have seen previously, and facilitate the early stage of the research lifecycle. So this is more what we are targeting by enhancing specific tools and services. So in terms of key impact and deliverable, so of course it's not the list of the deliverable on the right. It's mainly the type of the main product that we will produce. So I won't go into the detail, but regarding the impact, we have identified 5 main impacts. Facilitate the access to high quality, fair and multidisciplinary data to support cross-disciplinary research. And you will see that because we have onboarded 4 different communities into the LUMEN project to facilitate this cross-knowledge and cross-disciplinary aspect. Contribute to reusable EOSC-aligned services to the Federation via EOSC nodes, and especially by enhancing discoverability and semantic interoperability. So this is where we will propose the white label platform and the LUMEN infrastructure for semantics that we call the LUMIS. We also expect to enhance research efficiency and access to expertise with scalable, cost-effective, and educational tools, in particular through the AI-powered discovery assistant that we have called ADA, that facilitate the exploration of the different resources that we have in the different platforms. The fourth impact is about revolutionizing the research process by improving the user experience, reproducibility, and collaboration. This is why the different services we propose are based on different communities in order to provide different tools depending on the needs of the community. So it's really targeted to the needs of the community, such as meta search, chatbot, the metric, the visualization, and software catalog. And depending on the community and the user feedback, we know which kind of tools must be plugged to the platform. And the last one is about transforming data governance by fostering the autonomy, the interoperability, and the strategic alignment across the community. And this is really the whole architecture of LUMEN with the data mesh architecture that I will present in a few. I just added actually this slide during the first presentation because you will see that the LUMEN presentation is not focused on the details of the work package, but I thought that it can be interesting, especially if you want to build some connection between specific work package of LUMEN and other projects. So just for you all to know that we have, as usual, work package 1 and 8 dedicated to the coordination and communication and dissemination. And we have within we have more specific work package with the work package 2 dedicated to semantic artifacts management platform. This is where we have, for instance, the development of the LUMIS service. You can see that in work package 3 and work package 6, they are closely related because in the 3, this is where we study. We do the user research and the co-design through the involvement of different types of stakeholders. And in the work package 6, this is where we develop the different features adapted for the needs of the community. So the two are really important and are in constant dialogue in order to adapt the type of features depending on the user research and vice versa. And all of these work package contribute to build the discovery platforms in the work package 4. So this is where the 4 platforms that we build, I mean, some are already existing, but the 4 platforms are gathered in this work package. We have a full work package dedicated to the exploitation of the discovery platform. And this is where we do some connection on one side on the EOSC, but mainly on the EOSC related to the governance and the exploitation. And then we have also a full work package, the work package 5, interoperability and EOSC integration, which is much more technical, which is about how to integrate concretely our different services, our different products into the EOSC, what type of relation we to build with the EOSC nodes, and especially the EOSC EU node. So this is how we are organized. I won't go in. So if you have specific question or want to establish a specific connection.
Susan, I don't know if it was just for me, but your sound broke up for like 30 seconds.
Same here.
Yes, same here. Yeah.
Could you maybe just repeat the last 30 seconds or?
30 seconds. Yeah, of course, because I know exactly what I said during the last 30 seconds.
Yeah, that is exactly what I had in mind.
Okay, so first I will, I'm closing my video. I hope it will be better. And what did I say? So I was mentioning the fact that the EOSC aspect is managed in 2 different work packages. The work package 7 considering mostly the governance and the global strategy, and the work package 5 mostly regarding the technical integration of the different LUMEN output. And then I was just saying that we have several work package leaders of LUMEN here in the call. So if you want to set up some connection with them, feel free to let us know. And I hope now it's okay. And I will continue.
Sound is good, Susan.
Okay, good. Thank you. So what is the ecosystem as such? So first, quickly, it doesn't come from nothing, this LUMEN project. It really comes from the first Go Triple project, which closed in 2023, and which provide the Go Triple platform. So it was the Triple project, actually, who provides the Go Triple platform, which is the discovery platform for social science and humanities resource. And from this project, different communities have identified a need to also have a kind of similar platform, but for their own community. And all together, we wanted to facilitate the interoperability between this platform and to facilitate the cross discovery of the different resources that are gathered on the different platforms. So we have integrated into LUMEN. We still have the SSH community, but we have also integrated the Earth Science community, where we will create a similar platform as Go Triple for Earth system, another one for the molecular dynamics community, and we will upgrade another existing platform like Go Triple, but based on a different model for the mathematics community, with the support of ZBMat Open and Centre Mersenne. And all these 4 platforms are organized through a data mesh. So these are the scientific domain at the heart of LUMEN, and I won't go into detail because you will see, you will get the slide, but you can see in the smaller box in the different colors, the type of data and the type of services that are really specific to this community, and how we try to really be on one side very specific for each community, but in the other side facilitate the dialogue between them. So two core concepts for the LUMEN project, at the heart of the LUMEN project. The first one, which is the global architecture of the project, meaning a data mesh, which is a data exchange space amongst the community, so facilitating the exchange of information, of data, of resources between the community. And the other aspect, which is the providing 8 innovative tools to facilitate the discovery of data. And you cannot see them very easily here, but I will come back to that later. So these are the two concepts really at the core of the LUMEN project. And maybe what you can see here in this type of gray figure, for the moment in LUMEN we have 4 communities, and one of the key assets of LUMEN is also to provide a white label platform, meaning that we can create interoperability and connection with other future community, such as astrophysics, for instance, such as so any type of community. And we really hope to onboard a future community in this model, especially because the big advantage of a data mesh is its flexibility. So here, yes, you can see, so why a data mesh? So it's mainly to facilitate the interdisciplinarity. It respects the governance of each community and the specificity, while facilitating the dialogue and the connection between the community. So this is why we have a common discovery infrastructure, where the components are domain agnostic, where we provide federated services that are, we expect to be innovative. But we have also domain-specific components, and we contribute, or we address the interoperability and the integration with the EOSC. So the fifth, you can see on the right, the cross-domain, decentralized, fair by design, modular and flexible and autonomous. These are really the different advantages of the data mesh and these global architectures that have been sought, for the LUMEN project. And here you can see the list of the innovative tools that we have that contribute to allow data discovery. So the meta search that facilitates the search within the different platforms. The LUMIS tool, the unified platform for semantic artifacts, a metric service to identify the usage of the different platform. Data visualization tool, the white label platform that I mentioned, the chatbot, so the ADA tool that I also mentioned at the beginning, modular latex tool. It's especially for mathematics, but it's also there is also some usage for the SSH. So this is a tool that is for the moment mainly identified for the math, but it can be for other community as well. And the software catalog. So these are the different innovative tools. How do we propose how is it organized more concretely? So you can see here that we have 2 specific concepts that are key in the organization of the data mesh, the data construct and the data product. So the data product are really the type of data identified within the community. So you can see on the right that how this data has been identified through a resource with a contextual entity, and it provides with a specific data source. So this is the data product, and the data product must be explained, detailed, or detailed through a data contract, which exactly precise what is exposed and under which rule. So these 2 concepts, so the product as such and how this product must be exposed and what it is and how, are the 2 concepts of the data mesh architecture of the LUMEN project. And here, again, I don't want to go into details, but I really like this slide because it's really a good way to identify the different types of resources that we have and that we gather within the LUMEN project. So you can see we have publication, software, metadata, but in maths we have also theorem database. In molecular dynamics, we have some simulation as well, so the structure and the data set of the molecular dynamics. So very different types of data in each community that we try to harmonize in order to facilitate the discovery, their discovery. So what to produce to join the LUMEN data mesh? So it's more an explanation, but it can be also interesting for the other project if you want to join as well. But I think it can be a vice versa. We have also probably some results that we can expose in your discovery model. But here again, so the first one is to expose your data products through an API, something not very complicated and where we don't need the data. But much more the description of the data, and then attach the contract to each data product to facilitate the readability of the data. So in action, I'm not sure. I think it's very close to what I said previously, but it's another way to precise regarding the fact that we expect the platform to be interoperable, the role of the white label one, the fair by design infrastructure. So I don't want to detail as well. And maybe I would like to finish on a specific 3 use case, concrete use case to show how the different communities can work together, or how the LUMEN output can be concretely used, and the kind of impact we can expect. So first, through the meta search, one of the innovative tools. So we have identified that 3 communities, for instance, can be involved in that one. So it's how to trace microplastic across domain. So from the molecules to in the ocean, how they are transported into the ocean, and what kind of impact it has in terms of policy and health. So this is why it gathers 3 different communities: SSH, Earth System, and Molecular Dynamics. These 3 communities can come together, address this question of the microplastic across different domains and their impact later on the health, and what kind of policy we should set up. The second one is how to share data, what kind of shared data products we can have through the LUMEN data mesh. So it's more related to the software catalog that is developed in Work Package 6, so the one with the innovative features. And what we said here is that we can have instead of building, for instance, another harvesting system inside the white label platform in Work Package 4, we can expose the catalog as a data product within the data mesh to facilitate then the description, the identification of the right software, and then the fair metadata are automatically reused across the different discovery platforms. So this example, very quickly again, and we can go back to that during the question phase, demonstrate the cross work package federation, and not only work package, but also cross community, and how the data mesh architecture as such is organized. And the last one, which is more the synergies with EOSC, how our data mesh is aligned with the EOSC EU node catalog. So here it's mainly because both of them aim to make research products such as data, publication, and software discoverable and accessible across federated catalog. This is why we have seen a good synergy between the two, and that we expect to provide create some connection between the data mesh and the EOSC EU node resource catalog. And I think with that, yes, I was already, I think, a bit too long. So that's it for me. Thank you very much.
Thank you very much, Suzanne. And again, I will directly give the floor to our colleagues at Race Suite. And if I am not mistaken, it would be Evdokimos. Are you here? Ah, great.
Yes, hi. Can you see my screen?
Yes.
Okay.
So RAISE Suite, fair data from collection to exploitation. So we're a big consortium, 25 partners, and we started last September working on this. So the idea was that we identify the fears and concerns of researchers that towards data sharing. And with the first project that we had that finished last month, RAISE, we tried to cover and we managed to cover or to address actually partially these concerns. Now with RAISE Suite, we focus more on lack of recognition, time and effort needed, skills needed, and data protection. So before entering into details, I would say that in RAISE Suite, what we do actually is that we want to facilitate researchers to design their data management plan, to integrate some SDKs, tools in the instruments, data collection instruments, and then automatically data by complying to the data management plan to be collected. And once it is collected, then we move to the RAISE, to the second row here. Data will be accessible by data visiting and not data sharing. So what do we do in RAISE Suite? So actually, one of the tasks of RAISE Suite is to create a data management plan based on existing work that has been done in OS Trails following the RDA, and to give a persistent identifier to the data management plan in order to be findable, accessible, and reusable. So the data management plan, or at least our intention is that the data management plan will be the single point of truth, which means that all the different components that are involved in the data management lifecycle from collection to exploitation will be citing the data management plan in order to configure themselves to comply. So then we'll have the RAISE Suite SDK, which is actually will be using the PID of the data management plan in order to understand, in order to fetch the data management plan and facilitate or auto-configure the mechanisms for data collection, dataset accessing, dataset curation in order to follow or to comply with the data management plan. So this is, let's say, the scenario that you use the RAISE Suite SDK, you develop your sensing instrument, hardware or software, and then you add the PID, and then the sensing instrument starts collecting data by following the data management plan, and the dataset is created. So this is the RAISE streaming node. So we have intermediate nodes that facilitate this progressive collection of data towards the dataset. The idea is also to collect different metadata from the very first, from the data source to the data set. So the data set will be created progressively with all the data, with all the metadata. So the idea is also to support the collaboration among researchers in the data management plan generation, creation, so they work together. But most importantly, the data management plan exploitation, which means that it could be that two researchers that they don't know each other, they cite the same data management plan and they collect data with the same way in the same dataset. Or it could be that two independent researchers cite the same data management plan and they create two different datasets, two individual datasets, both of them having followed the same data management plan, which means that they have not only the same structure, format, or kind of type of data, but also the way the experiment ran. So from RAISE Suite, we end up with a dataset from the source to the dataset, and this dataset is the common point with the RAISE, which finished last January. And RAISE is about data sharing. So with all this, we want also to configure where the data is stored. So for instance, in RAISE, actually, we have nodes where you can store your data and then others can access it. And you can have your own data node, a private data node where you can have your datasets there, or you can use an existing public node. You can grant access to others who can process your data without downloading or seeing your data, and also control over results of your data. So you can note your dataset that requires result approval, which means that if a researcher processes your data, they cannot get the results until you see and approve. And here you can see the dataset marketplace of RAISE and RAISE Suite. We have developed also plugins in order to make sure that we don't disrupt the way researchers work today. We have also an static and dynamic analysis of the script in order to make sure that there is no something suspicious happening with the code, etc. And here you can see an experiment. Here you can see a data set processed by a script and the owners and the citation. And you can also allow others to download the results. So the idea is also we do it in RAISE, but also in RAISE Suite to provide metrics, usage metrics, who processed the data, how many times. So we try with the two projects to cover the full data life cycle. So from generation actually to the analysis. And we have in this project in RAISE Suite, we have 5 pilots in order to assess automated data collection or data collection coordinated by a data management plan. And if you can see, we have the pilots are actually covering the 5 missions of the European Commission. So the activities of the pilots will be data collection. So they will have to integrate the SDK in their sensing instruments, create a data management plan, and then deploy the sensors in real-life environment in order to collect data and generate data. So this will be the objective of the pilot partners. And we have also an open call for engaging externals. So we have 8 vouchers, 10K each. We will give them to companies that produce already sensing instruments in order to integrate RAISE Suite to their sensing instruments and pilot data collection in real life environment. So the success of the project in RAISE was if can data visiting technology reduce researchers' fears of data sharing in open science, while the objective of RAISE Suite is how much aligned with the data management plan is the data life cycle from source to sharing and processing. The idea is to create also, everything is exposed as an API, and I will explain why. And we create also SDKs libraries, and we have them available through the formal portals or marketplaces of the different organizations. And we don't want to be just another data portal, but we want to be the infrastructure for collecting and providing access to data. So the idea is for RAISE, or the objective for RAISE, is to be integrated in other systems, like I heard really nice presentations before. So we would see RAISE covering partially some of the activities of the other projects, integrated through an API as an infrastructure. The RAISE so far is TRL7, so RAISE Suite will build on top of RAISE. We have already some figures of existing datasets and publications using this PID of research analysis identified and already users. We have some early adopters, so now we're about to sign an MOU with the region of Central Macedonia using RAISE for data processing. But we have also, a very diverse, it's not only on research infrastructures or in the EOSC domain, we have very diverse target groups, like we have a football club to provide access to data that they collect from GPS sensors from the players, soccer players. And we have been featured as Project of the Month in January in Cordis. Please subscribe to the RAISE community or newsletter. This is the link. I will put it also in the chat if you want to be, to be engaged and to learn more or about our activities. Thanks.
Thank you so much. First of all, thanks to all the presenters for going through this presentation marathon.